All right, so it looks like we got people from Brazil, France, Spain, Germany, Ukraine, USA, India. Got a global crowd. Awesome. So we'll be starting in just about a minute. All right, I think we can get started. Welcome everybody from all over the world. Thank you so much for joining me this morning. Today we're going to be talking about data modeling in MongoDB. My name is Otto Kukic, and I work as a lead developer here at MongoDB. And I will be your host this morning, evening, afternoon. So with that said, let's dive right into it. So just a couple of housekeeping items as we begin. This webinar will be recorded, and the recording will be shared with everybody that that signed up. So whether you're attending here live or you signed up and couldn't make it, you will get a recording in the next couple of days. So all of our wonderful participants all over the world will be muted, but you guys can ask questions in the Q&A section, as well as leave comments in the chat and let us know how we're doing. And then at the end of this webinar, there will be a short survey, and your input and feedback is greatly appreciated. That way, we can figure out what type of content you guys want to see, and we'll create more of it. So let's talk a little bit about the agenda for today and what we're going to be covering. So to kick off the webinar, I'm going to introduce you to the document data model and what that means for your applications as you start building them. Then we're going to take a quick look at MongoDB Compass, which is a GUI tool for visualizing your MongoDB data. Next, and the kind of meat and potatoes of our presentation is going to be modeling relationships with MongoDB, and we'll cover a bunch of different use cases on how to best do that. Next, we're going to talk about evolving your MongoDB schema as you build out your application, as your application grows and evolves to meet new use cases. Then we'll discuss schema validation and how you can ensure that your data model is aligned with what you'd expect as your application grows. Finally, we'll discuss some MongoDB design patterns and anti-patterns, as well as discuss a really cool feature in MongoDB Atlas called the MongoDB Schema Advisor, which is going to give you a breakdown of the patterns and anti-patterns that you might be using in your application. So to get started, and kind of the main theme of this presentation, and the one key takeaway that I would like you to walk away with, if there's one thing you walk away from this presentation, it is this statement right here, that data that is accessed together is stored together in MongoDB and in document databases. And that if you take a relational approach to NoSQL and the document data model, you're very likely to have a bad time. If you just, if you're coming from a traditional SQL background and you kind of try to fit that into a document data model, you're going to run into all sorts of issues. So, with this webinar, I want to teach you data modeling, and I want to teach you about how to think about your data. So, if you do come from a relational database background, you're probably, well accustomed to database schemas that look a little something like this, where data is normalized as much as possible, and all of your data is stored in a series of tables, and these tables contain rows of data. And then when you need to retrieve your data, you typically have to merge one or multiple tables together to form a query and generate the data that you're asking for. And this can get very complicated very quickly, and you really have to plan out your application and plan out your data model way ahead of time, and making changes down the line becomes very painful and very unintuitive. And to give maybe a more abstract example, if we think of an automobile, a car, in a relational database way, we might not be thinking about the car as a whole. We might be thinking of the car as a sum of its parts. So its tires, its seats, its engines, its brake pads, and all of the other features that combine the car, as opposed to just representing a car as a car. So in MongoDB, we can have all of those attributes of a car contained within the car itself. So that's kind of an abstract example, and I just kind of wanted to get you thinking about the differences between relational databases and document data models. But now let's take a more programmatic approach to it. And this is something that I like to call a shift in your approach and a shift in your thinking about how you lay out your data. So when it comes to document data models, I want you to think application first, and think about how your application is going to consume that data, as opposed to how the data is actually stored in the database. So if we, again, look at that tabular relational data model approach, we split our records and we split our documents across multiple tables and rows. And when we need to get that data, again, we have relationships and we have joins that we'll have to do to combine and to create queries that will get us the data. As opposed to the document data model, where related data is contained in a single rich document that can have as much data as you need, and it can be nested. You can have arrays, you can have objects within objects, you can have various different data types to represent what you want to represent about your application. And again, I'm going to be talking about this all over the next 40 minutes. Data that is stored together data that is accessed together should be stored together. Let's take a closer look at documents in MongoDB and see how they work. So this is a sample document, and this document is one that we'll be using throughout the presentation to represent a movie, to actually represent our data model, and it's going to be a movie document. And if we look at it, this is essentially a JSON document that contains a list of key value pairs. So on the left-hand side, we have our key or our attribute. And then we have the value for that attribute. So our title is our key, and our value is, I do not want to restart the computer. Sorry about that. So a closer look at our documents, we have the key and then we have the value. Now, sorry about that. I just had a pop-up. Hopefully my computer does not restart, but if it does, we will jump back on a different one. The interesting thing about documents in MongoDB is that we can have the key and the value just like we would in a normal document database, in a normal relational database, but then we can also store more complicated data types, such as dates. In this case, we have a date type. We can store arrays, so where the movie was released, all of our different countries. We can have objects, so for our ratings, our viewer and critic ratings. We can have arrays that contain objects that could also contain additional arrays. We can get as complex as we need to really, represent our data model in a way that our application is going to be able to very easily consume the data. Now, the other important thing to note here is, let's see, cast. So that's a kind of brief look at documents within MongoDB and the document data model. Now, I want to show you how you can easily look at your data in MongoDB with a tool called MongoDB Compass. Now, this is a GUI tool that allows you to connect to a MongoDB database, whether it's hosted on MongoDB Atlas or a different database, or if it's self-hosted, or if you're hosting the database anywhere. It's a free tool that allows you to visually inspect and understand what your data is doing and how it works. So I'm going to switch tabs here to show you MongoDB Compass, and I'm running it here on my Mac. And I am in a sample mflix database in a collection called movies. And when I load up this section, when I load up this collection, I see a whole lot of information about all of the documents that are contained within the collection. And in this case, I have a number of different movies, 23,500 to be exact. And I can understand the data model. If I wanted to open all of the attributes for that document, I can see, its key, its value. If I needed to update it, I could just double click and I will get all of the data types for all of the individual pieces of information within the document. I can add additional fields or updates. So if I needed to change the plot to, something about the movie, I can do that here. Hit update, and that change will be automatically reflected, as well as we can add new documents. We can further understand our schema by hitting the Analyze Schema button here, and it's going to tell us, based on the documents that are within our collection, what type of data models they are, what they represent, when they were updated. And this visual way of understanding how our data is stored in MongoDB is very, very powerful. Additionally, we have the explain plan, which is going to tell us how our data is queried. We can run and create aggregations and all sorts of functionality visually without having to really write any code. So that is a brief introduction to MongoDB Compass, and it is a tool that it becomes really invaluable as you start building your application and trying to understand what your documents look like. So I highly encourage you to try MongoDB Compass, connect it to your collection, and you can do a whole lot here before you actually write any code for your application. But let's go back into our slides and let's start thinking about our schema. And let's discuss how we're going to go about designing our schema in MongoDB. And there are a couple of questions you want to ask yourself before you start designing your schema in MongoDB. And the first question is, what does my app do? So you're going to want to describe the workload. Describe, what your application is going to be doing, what your app does. Is it writing data? Is it reading data? Is it accessing, a specific set of data more often than others, and so on and so forth. The next question you're going to ask is, what does my data look like? You're going to want to identify and model these relationships. So this is kind of an exercise that you would do in a relational database as well. You're going to identify what data goes together, but the big question you're going to ask yourself here is, should I put this data together? Is it going to be accessed together? Or do I need to store it in a different collection? The third question you want to ask is, how am I going to access my data? And this is more concerned with the tooling that you're going to use. So are you going to use the MongoDB drivers? Are you going to use an ODM library to help you kind of identify the schema ahead of time? And then finally, how is the end user going to use my app? And this is where you're going to want to apply patterns, kind of well-established methods of describing and creating your schema in MongoDB. And we're going to talk about the various patterns that we have in MongoDB that are kind of tested, really battle tested and effective for really building scalable applications. So when it comes to modeling relationships in MongoDB, we have a couple of key things to consider. So, we've asked ourselves the questions, and now we're kind of, dealing with that second question, the big question about what did the relationships in MongoDB look like? And as I mentioned earlier in this presentation, MongoDB implements a flexible document data model, which allows you to store data in any way that you want. These documents support an embedded data model that allows you to build complex relationships within a single document. But if you need to, normalization can be accomplished with database references, and we'll talk briefly about that as we move throughout the presentation. And then finally, when it comes to modeling your relationships, the key takeaway is always that data that is accessed together should be stored together. And you are going to want to focus more on how your application actually uses this data as opposed to how it is actually stored in the database. So with that said, let's get into modeling the traditional one-to-one, one-to-many, and many-to-many relationships that many people coming from a relational background will be familiar with. And if you're not familiar with it, I will briefly explain what the relationships look like. So for our first relationship, the one-to-one, this is essentially that key value pair. You have a key such as the title of the movie or the ID of the movie, and you have a value to represent it. And in a traditional database, this works in a table, you will have the table key, and then you will have its value. Now, most one-to-one relationships are kind of represented in a singular table, but if you wanted to, and if you had a good reason to store additional data in a separate table, you could also do that by simply referencing the movie ID in the adjacent table and add the additional attributes that you needed. And in MongoDB, you might do something similar. So you might have a movies collection that has the key and value pair of the title and the value of the movie, the name of the movie. And then you might have a movie details collection that references that movie ID and then adds additional information such as the director, the runtime, and additional information about the movie. So while you could do this, this isn't the way to go about it. What I would do is store all of the one-to-one relationships, every piece of information that is relevant to the movie in that single collection. So rather than have a movies collection and a movie details collection, we would just store the one-to-one relationship, the key value pairs within a single document. So we would have our title, our director, our runtime, and any additional information about the movie in that single document. And this is kind of where MongoDB and the document data model really shines, because in a traditional SQL database, in a relational database, you have just a series of tables and rows. And essentially, if you think about it as an Excel spreadsheet, you can't really nest your data. You can't have complex relationships. You just have the top level key and the value associated with it. But modeling one-to-one relationships in MongoDB has the additional benefit of allowing you to embed complex objects within the main level document. So, we can add a filming location that is an object in itself that has an additional object for the coordinates of where this location is. And then we can also have the, arrays and all the complex data types that MongoDB supports. So that's kind of a primer on one-to-one relationships. The next one we're going to discuss is probably the one that most people will be dealing with and most folks have questions about, is the one-to-many relationship and how that works. And the one-to-many relationship, if you're not familiar with it, is a relationship in which you have one document that is going to be, or you have one piece of information that's going to have other pieces of information that are kind of duplicated. And one example of this is a movie is going to have many different actors comprised of its cast. So in a traditional SQL database, in a relational database, you're going to have a movies table, for example, that's going to have the ID, the title, the director, and other information about the movie. But when you want to represent the cast of the movie, you're going to have to create a separate table called cast, which is going to have the actor, the character, because the other alternative is you add additional columns in the movie table that's going to say, actor 1, actor 2, actor 3, actor 500. And if a movie doesn't have 500 actors, you're going to have a bunch of empty rows, which is never good in a relational database. So if you take that relational knowledge and shift it over to the document data model, you might think to kind of do it similarly, right? You would have a movies collection that's going to have the movie title, information about the movie, and then a cast collection that's going to have a reference to the movie, and then who the actor is, what character they play, and any other information. And so you would have one document in the movies collection for the movie and many different documents in the cast collection. And again, while you can do this, it's probably, and it's very likely an anti-pattern, because remember, data that is accessed together should be stored together. And typically when you get information about the movie, you'd want to get at least, the top characters and the top actors who are in it. So what we typically recommend in a document data model is to store data that is accessed together in the same document. So what we would do here is embed the additional information. Instead of having a cast collection, we would just have a cast key, and its value would be an array of all of the actors that played, all of the actors that had a part in the movie. And we can have as many actors as we want and as many additional information in this object for the cast. And this also makes it very easy to query data about, both the movie. So if we say, give me the information about the movie Lord of the Rings, we would get the movie and the cast information. But we could also say, get me in the movies collection, get me all of the movies that have the actor Ian McKellen, for example, and then we would get the Lord of the Rings and any other movies that he was a part of. So that's modeling one-to-one relationship or one-to-many relationships in MongoDB. The next one we're going to tackle is the many-to-many relationships scenario. And the many-to-many relationship, if you're not familiar with it, is you have a piece of data and you have another piece of data, and this data could be represented in many different collections and in many different scenarios. For example, the Lord of the Rings was filmed in many different cities, but also many different movies were filmed in kind of the same city. So the way that you would model this relationship in a traditional relational database is you would have a movies table that would have a list of movies. You would have a filming locations table that would have a series of columns and rows for all of the locations where movies were filmed. And then you would have what is typically called a join table that would have a reference to the movie ID and a reference to the city ID. And so you would do at a minimum a three-way join to get information about where a particular movie was filmed. And again, if you're applying this knowledge and kind of trying to transfer it directly from a relational model to MongoDB and a document data model, you might do something like a movies collection and a locations collection. And you can have that intermediary, movies locations collection, or you might do something like add a key of filming locations or property of filming locations and an array of all of the cities where the movie was filmed. And then in the locations collection, you have a list of movies, movies for the value or for the key, and then an array of all of the different movies that were filmed in that particular location. And again, this is something you could do, but I believe there's a better, more performant way to do it. And that is, again, to embed the data about the filming locations in the movie collection itself, because that is typically something that you may want to have when accessing the movie data. But again, if your application, for example, only has reviews of movies, then having the filming locations might not make sense because you don't want to get that data every time or have a really big document that has the filming locations if you are very rarely ever going to use them. So, your mileage may vary in this scenario, but I think either of these approaches could work, but I would always opt to put data that is going to be accessed together and store it together in a single document. Now, the other interesting kind of feature of MongoDB is this extended reference pattern, and we'll get into patterns and anti-patterns in a little bit, but I thought this would be a really good way to kind of introduce this pattern a little bit early, and that is to say that, let's say you have this collection of movies and you wanted to have a couple of the most famous filming locations of the movie, like Lord of the Rings, for example, was filmed in, I believe, like 140 or more locations and sets, but you may not want to get that full list. So in the extended reference pattern, what we could have is a top filming locations key, for example, that has the top 3 or 5 locations and their associated data, and then another key for all of the filming locations, which does just have the ID of the filming locations, so that if you wanted to get all of them, you would use the extended reference pattern and do a subsequent query to get location on what 106 is, what 117 is, and so on and so forth. So that's the extended reference pattern that is actually a design pattern of MongoDB that allows you to store the most important data, the most access data, but then have a reference to all of the additional data you may need about a particular document. Next, let's talk about evolving your data model within MongoDB and how that works. So, your application will seldom stay static and rarely ever change, right? Your application is going to have new use cases. You're going to want to add new features based on feedback from users, customers, and so on and so forth. So change is in your data model, whether it's a traditional relational database or a document database, change is inevitable. The thing with MongoDB, though, is that MongoDB's flexible document model makes evolving your schema effortless. And one common approach, and there's many different ways you can approach evolving your data model in MongoDB, but one of the really popular ones is called schema versioning. And essentially what we would do in this example is have a key value pair for the version of the data in our document in a single collection. So in both of these instances, we are working within the users collection, but we have 2 different documents. And the important data points that we have are in version 1 of our document within this users collection, we represent the name as just a single string. So for both the first, middle, and last name of our user, it is just a string character. But in our users collection, if we are using the schema version 2, and again, this could be letter A, B, C, or you can represent it however you want because you have that flexibility. But in version 2 of our schema, the name is actually an object that has various properties associated with it. So we have the given name, John, the middle, Franklin, and then the family or last name, Doe. So in our application, for example, let's just say we had an API that got users information, we might have, myapp.com/API/v1 that would get you the name as a string. And then if you hit that same endpoint with version 2, you would get the name as an object with the additional properties. So, that is one common approach to schema versioning and evolving your data model within MongoDB, but there are many, many other ones. And, the choice is really up to you. So you don't have to use this versioning schema. You can just add additional documents as your data model evolves and not keep track of it and keep all of the kind of data logic on your application side or on your client side, but schema versioning is one popular way to do it on kind of MongoDB side as you store your data in the document. Now, as your application evolves and gets bigger and you kind of solidify some features, you may want to kind of start enforcing a particular schema in the MongoDB document model. And this is something that is possible in MongoDB. So schema validation is a feature that allows you to validate that inserted or updated data conforms to a defined schema that you or your database administrator has enforced. And the schema validation, you don't have to start with it. You can have your data model evolve as your application grows, as you're taking it from a proof of concept to a production application to adding new features. But then you get to a certain level of maturity in your application, and you might want to say, this is enough. So we want to lock this schema in. And the best part about schema validation in MongoDB is that there are various levels of enforceability. So you can say, if a document is added to a particular collection that doesn't conform to the schema, we'll still accept it, but we'll send a warning or we'll log it. Or you can say, if a particular document that comes into a collection does not strictly have all of the data that we need it to, or doesn't conform to the validator that we sent, do not accept it and send out an error. And on the right-hand side here, I have an example of a validator, JSON schema validation, that tells us that our document is going to require that we have a name, year, major, so what major the student is studying, as well as their address. And then we can kind of go in a step deeper and talk about these properties. So the name property, it has to be a string. So a student's name cannot be a number, cannot be a date, cannot be an array. It has to be a string. And if it fails, if you try to pass in a number to the name property in the student's collection, you're going to get an error saying that this must be a string and is required. So that's a little bit about schema validation, and a feature that not many developers know about MongoDB, but it comes really in handy as your application matures and is kind of ready to be locked in at a certain state. Now, we talked about schema validation. We talked about modeling our relationships in MongoDB. Kind of the next thing I wanted to talk about was utilizing the design patterns and how to avoid anti-patterns in MongoDB. And MongoDB has many different design patterns that allow you to get the most out of the document data model. These design patterns are common practices that have been battle tested for many different specific use cases. And some of the design patterns, all of the patterns kind of have a unique name. And I'll talk about, 3 in specific, but I do have this chart on the right-hand side that talks about more of the patterns. But for example, one of the patterns is the polymorphic pattern, where a variety of different document types reside within a single collection. So we have a whole set of documentation on how to handle that use case. There's the pre-allocation pattern that, in cases where what your document structure is going to look like, you can pre-fill this data in each of the documents that gets inserted, and then you simply need to add the information as it becomes available. And then finally, we have the subset pattern, which solves the problem of having too much data per document in a single collection. And kind of that subset pattern, we showed it earlier when we were talking about the filming locations in Lord of the Rings. Some of them, you might want to have the top 5 locations, and then the all filming locations property would have all of the additional. So that would be an example of the subset pattern. Now, these patterns, they can be applied to various use cases, and this chart shows you that based on the type of application you're building, the type of pattern you may consider implementing. So if you are building an IoT application, or you have an IoT use case where you're collecting a lot of data, using the approximation or bucket pattern might be the way to go. Whereas if you have a content management type applications, the attribute or the polymorphic pattern might make more sense to implement. Let's take a look at one of these patterns a little bit more closely. So we'll take a look at the outlier pattern. And the outlier pattern works simply like this. Let's say you have a bookstore and you want to keep track of all of the books that customers purchase, or you want to keep track of the customers that purchase a specific book. And one of my colleagues here at MongoDB, Ken Alger, let's say he wrote a book on the genealogical records of his kind of family line. Now, I love Ken, but you know, he's not super well known in the world. So, you know, I'll purchase his book and maybe a couple other people, but it's probably not going to be a New York Times bestseller. Whereas J.K. Rowling, on the other hand, if she were to write the next Harry Potter book, it is very likely that she will have thousands and millions of sales within a very short period of time. And let's say we're running, you know, a small bookstore that is, you know, typically going to sell 15, 20 copies of a book over a period of time. It wouldn't make sense for us to design our data model around this outlier, you know, J.K. Rowling, or, you know, these one-off instances where we're going to have thousands and millions of customers purchasing a book. So to apply the outlier pattern, we would simply add an additional attribute. In this example, we would add a has extras property with the value of true. So if we exhaust our array, you know, our max number of customers in the document that we want to hold, and in this case, it looks like, you know, we're holding 1,000, then this property has true is going to tell us that, you know, we have a collection, an additional collection that has all of the other customers that purchased this book. So in most use cases, when we're accessing our sales records, we can just query one document. But when we do run into that outlier, you know, we might have to run 2 queries to get the additional information. So that is an example of the outlier pattern, design pattern in MongoDB. Next, I want to talk about a couple of different anti-patterns that MongoDB as well, that MongoDB has that you want to try to avoid. And we'll take a look at a couple, we'll take a look at one concrete example, but a couple of common anti-patterns to look out for is the first one, massive arrays. So storing massive unbounded arrays in your documents. And we saw that example earlier with the J.K. Rowling document. If for every customer that purchased the book, we included their information and we had millions of books purchased, that array would get very, very massive. Our document would probably exhaust its max of, you know, 16 megabyte size, and our performance would suffer greatly. So we typically don't want to have unbounded arrays in our documents. Next, we want to avoid a massive number of collections. So storing a massive number of collections, and especially if they're unused or unnecessary in your database. So again, remember, you don't want to take all of your relational database knowledge and try to transfer directly to MongoDB and normalize your data. You want to store data that is accessed together in the same document. Next, unnecessary indexes. So storing an index that is unnecessary because it is rarely used or redundant, or because another compound index in MongoDB covers it. So indexes will take up more space in your database, and if you're not using a particular index, you know, it makes sense to drop it, or if you're using it very rarely. And we'll talk a little bit about indexes as we get to the schema advisor, but we'll hold off on that for now. The next anti-pattern to avoid in MongoDB is called bloated documents. And what this anti-pattern is you storing large amounts of data together in a document when that data is not frequently accessed together. So, you know, you've heard me talk a lot about data that is accessed together should be stored together, but that does not necessarily mean that you should store all of the information about a particular document about a particular, you know, feature or document in the same collection. And then finally, separating data that is accessed together. So separating data between different documents and collections that is frequently accessed together. So, you know, you don't want to apply You don't want to apply traditional SQL knowledge to a document data model, because if you try to fully normalize your MongoDB collection, your MongoDB database, you're going to run into the use case of, having to run a lot of lookup operations to, create joins in MongoDB, or you're going to be running a bunch of extra queries, and that's not going to be very performant. So let's take a look at one of the anti-patterns, do a closer look like we did for the patterns. Design patterns, and we're going to take a look at the bloated documents anti-pattern. And in this example, we'll go back to Lord of the Rings, the example we've been using throughout this webinar. And in this case, we have some information about the movie, the plot, when it was released, who the cast were, the ratings. But now, we might want to store reviews on the movie as well. And so, a review is going to have a publication, the review, maybe the rating score, and et cetera, et cetera. So we might think it's a good idea. Let's just put all of the reviews in that document as well. And then we also want to share some, fun facts about the movie with users of our app. So we might say, let's create another array that has all of the facts about a movie. And, you can kind of see where I'm going with this. You can add all sorts of data in this document, but if on your initial load in the application, you're just getting a couple of pieces of information, like the title of the movie, the plot, and the cast, this additional information is going to go unused, and you'll still be querying it, and it's going to really cause your performance to suffer. So consider that data that is accessed together should be stored together, but that doesn't mean that you should put everything in the document that pertains to that particular document. Now, to close out, I do want to talk about the MongoDB Schema Advisor that is available in MongoDB Atlas. So the Schema Advisor essentially is an automated tool that is going to recommend improvements to your schema to make sure that MongoDB runs more performantly. And so, if you're just getting started with MongoDB and you're kind of worried about, am I going to run into all these anti-patterns? Is my application going to, work great at the beginning, but then as I scale it out and have a lot of users, is it going to slow down? The Schema Advisor is here to help. And it's going to help you by recommending improvements such as telling you which indexes to create, noticing and trying to identify anti-patterns, such as avoiding unbounded arrays, asking you to reduce the size of large documents where data isn't accessed together, reducing the number of lookup operations, and so on and so forth. And in your MongoDB Atlas dashboard, you have the Performance Advisor tab, and it's going to run automatically. And when it finds issues in your schema that haven't come yet, it's going to show you those improvements and kind of give you next steps on how to implement them. So that is the MongoDB Schema Advisor in a nutshell, and it can really help you kind of as your application grows, especially if you're just getting started, to get the most out of MongoDB. Now, I do want to leave you with a couple of additional resources, and we'll get to the Q&A in just a couple minutes as well. But if you want to learn more about the patterns in MongoDB, all of the patterns that I talked about earlier, we have this blog post on the MongoDB blog that is going to summarize all of the patterns that I showed in the graph earlier and use cases and examples of them, as well as a summary of schema design anti-patterns and how to spot them in your application. And then finally, we also have a blog post on MongoDB schema design best practices that you can use as a reference as you start building out the application. And it covers a lot of the same stuff that this webinar did. So with that said, I do want to thank you guys so much for joining me today. I hope this was a gentle introduction to data modeling in MongoDB. And I'll be here to answer a couple of live Q&A questions. But for now, we would really love to hear some of your feedback with the survey that's going to pop up on your screen in just a few seconds. So please, over the next 2 to 3 minutes, share some of your feedback, and we'll get to the live Q&A in